Greeting everyone and welcome to this educational channel. Our topic today will be about iron, and iron is an element with an atomic number 26 and atomic mass 55.8. I want you to memorize the atomic mass 55.8 because you will need it in your future calculation. Today I will be focusing on the iron that is present in the water. Now iron in water comes into two forms. The first one is a ferrous and it is in dissolved state, and the symbol of this one is Fe+2 and it is a colorless. The second form is being oxidized to ferric and the symbol is Fe+3 and it's a rusted color. You can indicate the presence of iron by color indication, like when it is in the ferric insoluble state, and it is easy to remove the iron in this state by using sediment filters or filtration. But it is a little bit hard in the case of dissolved iron or ferrous iron. You will need a unit like ion exchange or a softener, or maybe oxidizing filters or media to turn the ferrous to ferric, then remove it by filtration. If you notice an increase in iron result, that is probably an indication of a corrosion or maybe a presence of iron bacteria. Now iron bacteria are a small living organism which naturally occur in the soil, shallow groundwater and surface water. What happens is the iron and oxygen will combine together to form a rust, bacteria cells and slimy materials that binds to the wells pipes, pumps and plumbing fixtures. How will you know there is a presence of iron bacteria? First, typically iron bacteria smells like rotten eggs, sulfur, and it's similar to the H2S cases. Also, you will notice a chronic stains like reddish orange slimy stains in a sink or in a toilet. Now, how can you eliminate iron bacteria? You have an option to chlorinate the well, but this is a temporary solution, and you can go for ozone gas, which oxidizes the iron and the sulfur in the water, and this is gonna kill the bacteria. And you can go for chlorine injection process before the filters. One of the test methods that is used to indicate iron is ferrover method. You can go for a soluble and insoluble iron using this method. If you are aiming to do a ferrous iron only, make sure to filter your sample first. First, collect a sample in a bottle that been cleaned with 1:1 hydrochloric acid, and then rinse it with the distilled water. If you want to store the sample to use it later, acidify it first with the nitric acid and bring the pH less than 2. If you want to start the analysis back again, bring the pH to 3 to 5 using 5 normal sodium hydroxide. Now let's start the test. Switch on your spectrophotometer and select the right program. The iron program is 265. Now rinse 2 sets of a sample with deionized water, then condition and fill them with your water sample. Add the content of 1 ferrover powder to one of your sample cells. Swirl to mix your sample. Any extra undissolved powder will not affect the accuracy of your test. Start a timer of 3-minute reaction time. An orange color will develop if your sample contains iron. If the sample contains visible rust, add 5 minutes to total reaction. Now use one cell of a sample as a blank to zero your instrument. Then read reagent sample after the time is expired. Now here is a summary of what we talked about in this video. We talked about the two types of the irons, the ferrous and the ferric. We highlighted how to remove those two types of irons. We talked about what causes an increase to iron level in water. We understand what is iron bacteria is and how to remove it. We talked about a ferrover method for analyzing iron. We reached to an end. If you like this channel, please support it with a like or share it with your friends.